Okay, let's now discuss about Poisson's ratio. Earlier you have seen the extension for this rectangular bar and for conical bar, gamma L square by 6e. Now today we will see the Poisson's ratio. Poisson's ratio, it is what? It is the ratio of lateral strain to the linear strain. If this bar, it is applied a tension force of P, so it will change its length accordingly in the linear direction and also in the lateral direction. So the ratio of strain to that lateral direction to that of linear direction, that is Poisson's ratio, and it is denoted by mu, or suppose 1 by m, and that equals to lateral strain divided by linear strain. Okay, now volumetric strain. Volumetric strain is what? Suppose a member is subjected to stress, so that member will undergo deformation in all direction, and due to that deformation there will be change in volume. So volumetric strain is nothing but change in volume by original volume. अगर हम change in volume को del V से represent करें और original volume को V से represent करें, so the change in volume is del V and volumetric strain will be change in volume by original volume. Okay, एक important definition है जो that volumetric strain, it is the sum of strain in three direction. Volumetric strain, it is the sum of strain in three mutually perpendicular direction. जो suppose there is a bar or rectangular bar, you can say. If I consider three direction, say this is x, say this is y, and this is z, then its volume will be what? LBD. So if I find del V by B, so I will get del L by L plus del B by B plus del D by D. So I can prove that volumetric strain is the sum of strain in three mutually perpendicular directions. Okay. Now the very important topic is elastic constant. So in elastic constant we will discuss three things. The first is E, the second is G, and third is K. So what is this? E, it is nothing but modulus of elasticity, or we can say Young's modulus. G, it is modulus of rigidity, and K, it is bulk modulus. Okay, we'll discuss this shortly. Modulus of elasticity is nothing but linear stress to the linear strain, and modulus of rigidity is the ratio of shearing stress to the shearing strain. And bulk modulus, what is bulk modulus? You have to remember this. Suppose imagine there is a body, and in this body if we apply stress in three mutually perpendicular directions, suppose in x direction, y direction, and z direction, then bulk modulus, it is the ratio of the stress applied in three mutually perpendicular direction to the volumetric strain. Again I am repeating it. Bulk modulus, it is the ratio of the stress applied in three mutually perpendicular direction to that of the volumetric strain. So this is the bulk modulus. Relationship between E and G, everyone here we know this. E equals to 2G 1 plus mu. Relationship between, this was the relationship between E and G, that means modulus of elasticity and modulus of rigidity. Relationship between E and K, that means relationship between modulus of elasticity and bulk modulus, that is E equals to 3K 1 minus 2 mu. Relationship between E, G and K, that equals to E equals to 9 kg divided by G plus 3K. Okay. So this was the three important relationships which one you have to remember. Now we will discuss strain energy. So what is strain energy? The energy which is stored in a body due to straining of the body, that is called strain energy. कोई भी अगर बॉडी है उसमें अगर उसको अगर हम टेंशन देते हैं, सो ड्यू टू दैट टेंशन, ड्यू टू प्रॉपर्टी ऑफ इलास्टिसिटी, the body will get deformed, and after that deforming there will be a resistive force developed. If that resistive force, if the deformation is zero, then resistive force will be zero, and if there is some deformation, then obviously there will be some resistive force. So strain energy, it is the important formula, strain energy equal to half into stress into strain into volume. Okay. Resilience is what? It is nothing but strain energy per unit volume. So if you divide that strain energy divided by volume, so it will be half into stress into strain. And by putting the stress and strain value, you will get one formula. Suppose the stress is, we know from Hooke's law, stress equal to modulus of elasticity into strain. And so half into, suppose stress I am not changing, I am changing only the strain, so that strain will be stress by modulus of elasticity into V, so that will be half sigma square into V, half sigma square into V. And if you put that, another formula will come there. Okay. Now prove resilience. What is prove resilience? The maximum strain energy which can be stored by a body without undergoing permanent deformation is called prove resilience. And its formula will be what? Suppose if sigma is the stress, then sigma square divided by 2E, that will be the formula of prove resilience. Temperature stress. Okay. Now we will discuss temperature stress. Change in length due to change in temperature. अगर चेंज इन लेंथ को हम डेल से डिनोट करते हैं, तो चेंज इन लेंथ ड्यू टू चेंज इन टेम्परेचर इज डायरेक्टली प्रोपोर्शनल टू change in to temperature and length of that member. And if I remove that proportionality constant, so del equals to suppose k into T into L. This k is what? It is nothing but coefficient of thermal expansion, and the value of coefficient of thermal expansion for steel, it is 12 into 10 to the power minus 6 per degree centigrade. So temperature stress is what? Del equals to k into T into L, or in another book they are replacing the word k as alpha into T into L. Okay, suppose this del equals to alpha into T into L. Now this del is what? It is nothing but change in length, and we know that by formula PL by AE is del. So PL by AE, that equals to alpha into T into L. From there you can find P by A. If I cancel, the L will be cancelled. P by A, that it will be alpha into T into E. So P by A, load by area, it is nothing but stress. This is called temperature stress. So what is the formula of temperature stress? Alpha into T into E. Okay. So today up to that much. The next day we'll start the very important topic, that is shear force and bending moment.